question is, when is there a half and when is there not a half? And if you look, the half is here when you don't have the RMS. And the reason why is because for sinusoids, the RMS is the maximum, the peak, the amplitude, divided by the square root of 2. And so since RMS, so for sinusoids, which these are, V RMS is the same as V over square root of 2, and this is I over square root of 2.
You don't want the full. Because you want to find the peak at the,
Okay, the average value is the maximum divided by the square root of 2, and so that, or the RMS is. And so when I multiply V RMS by I RMS, if this is V max and this is I max, which is the same as the amplitude, those square roots of 2's become a 1/2. And that was a conjugate. So that's where the 1/2 comes from. So you do need to be careful, because if you are given RMS, then you don't have the 1/2 in there. But if you're given V and you want to just use,
explicitly say either or. It's not
yes,
like you have to-
yes, but it's not. But they don't remind you to check it. And so if it's not given to you in RMS, to get it to RMS, you need to divide it by square root of 2.
So if it's not RMS, you need it to be divided by the square root of 2.
Right. So if V equals 20 angle 30 degrees volts, V RMS equals 20 over square root of 2 angle 30 degrees volts.
Well, how do we know which one we use phasors and which ones we use magnitudes and which one is...
Yeah.
I think he wants RMS.
Okay, so RMS, if he gives it to you, he will either give it to you with an RMS or not. But your question was, does it have an angle or not? And so that is, you get the same answer whether you have the angle or not. It's just it doesn't give you an angle if you're using one without the angles in it, if that makes any sense. Like let me show you on the problem that I did, the first problem that I did. And
We also have a chart.
I have a chat. Would it be possible to, it would have been possible if somebody had emailed me before in the middle of the session. Yeah, okay, but I can show you how to do it, though. You won't have to do it on a test because you won't have to solve a complex system of equations. Is it more than 2 variables? If it's 2 variables, you might have to, but I doubt it. Just 2, okay, I'll look at it. All right, but if it's more than 2, I would use MATLAB. But going back, this first question, so we're talking about angles. So if you look at how I did, at Z2. When I did Z2, I included all the angles, and I got my answer with an angle. And when I did Z1, I used the formulas without the angles, and I got the answer without the angle, and I found the angle using this. So I used this. No, I used this. I think I used this. Yeah. I used this, which does not have any angles in it. Because that's what I had. I had the average power. And then I found the angle. I found the angle from using the formula.
Okay, we're just looking at one of the examples, ultimate solutions he has it. He has 1/2.
Can you tell me which example?
Page 9 of the AC model, but it's not to do the example, it's just that he used 1/2 I squared Z. So
I squared Z. Yeah,
so
because that would mean this is not, okay, because here's how I remember it. I know V equals IR, and I know that P equals IV, and those are the only ones I ever remember, so if I have to find others, I plug in from those. And so power equals I squared R, and if I change that to impedances, it's power equals I squared Z. Okay, but that's RMS. That's RMS. And so if it's not RMS, then I have to put the 1/2 in. And so probably nowhere in there does it say RMS, which is where the 1/2 comes from.
So it's 1/2 because it's going to RMS?
No, the formulas, all of your formulas will be if they are RMS, they're just like what you had in DC. If they're not RMS, you put the 1/2 in. So like, because, okay, so this is what we've always known. But I do know that IRMS equals I over square root of 2. The formula that I've known forever is good for RMS. So this is really RMS squared Z. But if I wanted to use, oh wait, do I have this backwards? No, I don't have it backwards. So, like, if I'm looking here at I squared RMS X, this is I over square root of 2 squared X, and so that's I squared over 2X, which is 1/2 I squared X. If you could, I know you can't read that, but that's where it's coming from. Did I write it backwards here? I think I did just a minute ago. No, I didn't. I wrote it right. Okay. Did I answer all of the questions that were asked? Oh yeah, the system of equations. AC power practice.
Yeah, that one was a bit
Extremely bad.
Is it on the is that in the introduction? Where are these? Okay.
Yeah. It's on like the second tab of the introduction.
Second tab of the introduction?
Yeah, all the way up to the top. AC power to
Question at the bottom of page 3.
it's like
I have it looked up if you want.
variable currency.
Yeah. Okay, so it looks like we get down. So I'm assuming you know how to get to the equations. It's just solving the equations is the question that you have? Yes, okay. So I'm going to write the equations here and we'll solve them. Oh, wait. Sorry, this was, can you read it to me?
2 minus J1 times I1 plus 6 minus J1 times I2 equals to 0.
Okay, so first of all, personally, I don't ever do these by hand anymore because my calculator does them. I have an Inspire CAS, and I recommend that when you get into even upper level classes, you get either that or an 89 titanium, so then you don't have to even deal with things like this anymore. But if I had to deal with something like this, there's no way about it is going to be fun, but probably the easiest way is going to be to solve one of these equations in terms of the other and then plug in, and then you just have a lot of complex arithmetic to do. So if I start with this bottom equation, 2 minus J1 I1 equals minus 6 plus J1 I2, or I1 equals minus 6 plus J1 over 2 minus J1 I2, and then I find out what that is. And by the way, the non-graphing calculator that I recommend, the TI-36, it lets you put complex numbers in fractions, although the 84 does not. So if I want, can someone tell me what it was? The fraction that I'm trying to simplify?
We don't include the current source for the second equation.
So you are finding I1 from the second equation?
I'm trying, I can't move the thing out of my way without, let's see. I was just trying to like do this arithmetic, this minus 6 plus J1. So, minus 6 plus J1 over 2 minus J1. So I was just trying to do that. There's something in the chat? Okay. And that is minus 2.6 minus J.8. Okay, and then the chat. Yeah, it won't do it. It won't solve them. Yeah, no, the TI-36 will not solve a system of equations with complex numbers, which is why I'm working this one out by hand. But the TI Inspire CAS will, as will the TI-89 titanium. So I1 equals minus 2.6 minus J.8 I2. So now I plug that into my other equation. So 2 plus J2 I1, and then I1 is minus 2.6 minus, I should have solved for the other one, minus 2.6 minus J.8 I2 minus J1 I2. I never used Cramer's rule. Rabelais loves Cramer's rule. I hate Cramer's rule.
He said you don't have a choice. You have to use Cramer's.
I've took Rabelais for many classes, and I never once used Cramer's rule.
That's what I used to solve it.
Yeah, you can use Cramer's rule. If y'all really want me to use Cramer's rule, I'll do it, but I'll not do it in front of people because I'll make too many mistakes. I'll do it and I'll record it later, but I hate Cramer's rule. So, but this way will work fine. And so here, I would just multiply this out, and I'd get the coefficients and add together and divide. So this is just the same as, this is a number times x minus a number times x equals some other number, and then you just solve from there.
It's too much extra for no reason.
Too much extra.
The thing about Kramer.
Oh, yeah, yeah, so then, so like, to finish this, I would multiply times 2 plus j2.
What happened to 2ic in this problem?
What the question?
Oh, because
You just ignored it?
no, IC is I1 plus I2.
I didn't write the equations because I was starting from given that we had equations left to solve. Yeah. And then that one you could go ahead and plug in and solve for that. So minus 3.6 minus j 6.8. I2 minus j1 I2 equals 10 angle 25 degrees. Combine like terms, this is minus 3.6 minus j 7.8 I2 equals 10 angle 25 degrees. And I get that I2 is 1.16 angle 139.7. I2.
Yeah.
What did I just say?
I got one. You got 1.46.
136.6,
Yes.
something like that is I2. And then I would plug back in here, so I'd multiply that by minus 2.6 minus J8 to get I1. Did I multiply by the right thing? I think so. And so then that would be 3.16 angle negative 23. Angle negative something. Yeah. Okay. So yeah, Rabelais really likes Cramer's rule, and he'll tell you you have to use Cramer's rule. And I can tell you that you do not always have to use Cramer's rule. I have.
Yeah, he meant like for the purpose of you getting all the points.
I don't think so.
Nah.
Oh, that's what
He'll say
said,
it.
no, you have to show Kramer.
You have to show your work. You have to show your work.
So it was a play on words.
I mean, okay, because he really likes Cramer's rule. In his head, what he's saying is, if you do this out and you do the work, you will be using Cramer's rule, and so you have to show it. And so, but if you show your work and you're doing it some other way, you will get credit for it. You're not going to not get credit because you solved a system of equations using another method. Now, so what he's saying is you can't use like I would do and just refuse to do it on principle and use my calculator to do it. You can't do that. But doing it like I did here is fine. Okay.
But KJT has a problem where he wants us to use Kramer's rule as we
Y'all are gonna make me do Cramer's rule?
It just looks like it would take
Page 8.
least that's how I try to solve
This one?
it. Yeah.
Um, this one, there is no nice way to do this one without technology. And so I wouldn't. I just, yeah, I put my foot down. I'm not doing it. Now, if you plug in values here and you get complex numbers, do we have what I is? Yeah, we
That's too
do.
much of a long probability
Yeah.
test, right?
Yeah, he wouldn't give you this on a test.
Yeah, that
No.
looks so hard.
No.
I started the problem
No.
and got like
He wouldn't give
halfway
you that
through
on the
and I'm
test.
like, nope. I closed my book.
Nope. Yeah, it's now the idea behind it. I mean, yes, but not this amount of calculations on a test. I mean, and the truth is, if I actually did have this amount of calculations to do on the test, I would set the problem up, and then I would say solve this, and use these numbers. You know, I mean, I just like that's the yeah. I mean, I don't stand a chance of getting the right answer even if I tried to do it by hand, because I can't. Okay, so going way back when, on the worksheet that I provided, are there other questions that y'all have, the preference that you would have for me to do on those, if that makes any sense? Number 3? Okay. Parts A and B. Okay.
Well, because like a quick one of those problems, 5 minutes.
Okay. Put transfer function to standard form, label factors. That's a problem. Okay, next one. Don't copy all this down. And the question is, determine resonant frequency. So you look at that, and you're like, and you do have some numbers, and you're like, oh, what? I thought I'm supposed to finish this in 50 minutes. And then you say, wait a minute, I remember what Rebecca said. We don't care about the denominator. We don't care about the real part. We only care about the imaginary part. And the imaginary part's right here. And that's the part that would need to equal 0. It's already kind of factored for us. And so we don't worry, the J, so it would be omega R L2 equals 0. That gives us the trivial one that we don't need. And then we get omega squared L C1 plus C2 equals 1, or omega equals the square root of 1 over L C1 plus C2. And then you plug in your numbers and you're done.
So you don't even need to multiply by the combinations.
No, because he was nice. He gave it to you already. There's nothing imaginary in the denominator. That's why.
But there was.
If there was, I mean, I could easily see this and then have it being plus let's say plus, say it was plus j omega. Let's say it was plus j omega. Then what you would multiply this, actually it wouldn't be like that, because that would end up with this part times this part being imaginary, and that would be too big. But you could have something where multiplying by the conjugate still gives you not very many calculations. So like if I had, this is going to be the last thing that I do. So okay, so if I had this, then multiply by 5 minus 3j omega, or 5 minus 3j omega, and the only imaginary part is going to be this times this, which would give us omega equals 0, which is not a very good example. But. Okay, so that one, and then the next one was one that y'all haven't gotten to yet, so that would not be one that's on yours. So there was another question that was, I would say, I'll come back to an example of like how long it would be. So then there's another one, convert to decibels, and so you need to remember a power ratio. You do 10 log whatever your ratio was, and for voltage and current, it'd be 20 log whatever your ratio is. I just have R standing for ratio. There's also a question of how many decades between omega 1 equals, say, 5.3 times 10 to the third radians per second, and omega 2 equals 7.9 times 10 to the sixth radians per second. You know that there are roughly 3 decades between them, because there's 3 powers of 10 in between. But if you want to get exactly how many there are, then you use log, because log tells you how many powers of 10, the log of omega 2 over omega 1. So it'd be 7.9 times 10 to the 6th over 5.3 times 10 to the third, and then take the log of that. And that's log base 10. And I get 3.2 decades, which matches about what I thought it would be. Okay.
What do you do the 20 log of 1 meter minus versus for the decibels? Like it could be negative
Okay. So you have a lot of things that were done. So a lot of stuff that you have is stuff that was done. We don't necessarily need anymore because we have technology. But so if I had 20 log omega 2 over omega 1, that is the same as 20 log omega 2 minus 20 log omega 1, which is how we, way back when, when I was in high school and we had calculators, but they weren't sure if this calculator thing was going to catch on or not. We had to look things up in log tables and do this. But you don't have to do this if you have a calculator. It's exactly the same.
Without using the other thing.
Well, it has a 20 on both of them. Oh, this one, yeah, it's the same without the 20. So the log of A over B equals the log of A minus the log of B. So this is just having the 20 out in front. Oh, and by the way, the problems where you have to find the exact value of the transfer function, or the, how's the question worded? Yeah. So, it's wrong. I find a lot of times it is easier just to okay, so the power gain is 20 log m, where m is the magnitude of the transfer function. Okay, so let's say I have the transfer function is I'll just leave it like that. And I'm supposed to find the exact value of the gain. All of our formulas that we have, so all those formulas we have that say, well, what to do with this and what to do with this and what to do with this, they all just come from the properties of logs. The magnitude of the gain is still 20 log magnitude of h. And so if I want to find out what the magnitude of the gain is at omega equals 100 radians per second, if I have a calculator that doesn't mind doing complex numbers, I can do 1 plus j times 100 squared over 2 times j times 100 times 1 plus 2 times j times 100, and get that answer, and then use my complex menu to find the magnitude, because this will be a complex number. And then once I find the magnitude, I take 20 times the log of it, and that is the answer. And that's the same thing you get from using all of the simplifications. And so it can be a way to check it. And it looks like I am going to have to shut down here. I will try to post some more examples later on. If there's anything else, like specifically that you want me to do, I will do a Cramer's rule. I'll do a Cramer's rule. Anything other than a Cramer's rule?
I'm sure we'll think of stuff in the next couple of hours.
Yeah.
I'm trying to get my formula sheet down.
Okay.
How do you pronounce it? Is it Bode?
Bodhi.
How does it pronounce?
I don't know. I assume it's named after someone, and however someone pronounces their name is what it is.
You guys see those videos that are posted?